Okay, passage 6 is a conflicts passage. Conflicts is kind of like looking at the differences in teams in an unusual sport. You got to first figure out what is the conflict and then figure out what are the differences and how they approach the conflict. So one of the things you want to consider when taking the ACT is when you take the conflicts passage. So that's always very important. It's a reading heavy passage. You can't shortcut it. You can't go straight to the questions. So if you're a strong reader, this is probably a passage that will work well for you, and you probably want to do it first. If you're a really weak test taker or a weak reader, you might want to do it last because you may not have time to finish the test. But this is the one passage that is kind of interesting about when you choose to do it. In this particular test, it appears at the end of the exam, and so if you're saving it to the end, it works well, but if you want to get it out of the way first, you'd have to find it and do it first. So your first question is, what is the conflict? And usually you're going to find this in the beginning where it says demonstration in this one. So a science teacher, poured 400 milliliters of water into a beaker, heated the beaker. After a few minutes, bubbles began to form on the water and float to the surface. 4 students were asked to explain how the bubbles were formed and to describe the composition of the bubbles. So how the bubbles were formed and describing the composition, that's the conflict. The next thing you want to do is identify the differences. Remember, we're looking for how the bubbles were formed and to describe the composition of the bubble. And so this student 1 says, as the water is heated, chemical bonds between hydrogen and oxygen atoms break. So hydrogen and oxygen atoms pull apart. The hydrogen dissolves and the oxygen remains. So the oxygen forms the gas bubbles. You might want to make notes out the side. You might want to underline it. It all depends on how good of a reader you are in doing this. I like to make notes out the side to answer the 2 questions, being how bubbles form and bubble composition. Student 2 says student 1 is correct in how the bonds, chemical bonds break down. So they're saying again, the bonds break, but the O2, the H doesn't dissolve, so you have a mixture of O2 and H2. So bonds do not break, H does not dissolve in the water, so the bubble, when the bonds do break, H does not dissolve, and the bubble composition is hydrogen and oxygen. Student 3, we have a difference here. It says the chemical bonds do not break. So students 1 and 2 said chemical bonds do break. They say they do form new molecules. So that's something similar. They both said they form new molecules. When the hydrogen bonds creates a thin circular sheet. The sheet comes in contact with the surface water. Air pressure pushes down, causing it to bow in the middle, creating a bubble. So they even give you a picture. So the bubble contains a mixture of gases only, air. So how bubbles form? H creates new bonds, forms a sheet on the top. Air pressure creates a bubble, and the bubble composition is air, a mixture of gases. Then student 4, as water is heated, chemical bonds are neither broken nor formed. So nothing happens as far as breaking or forming new bonds. The water begins to change from liquid to gas, forming bubbles containing water vapor only. So water changes from liquid to gas, and the bubble composition is water vapor. So yours may look something more like this, where you have a few notes out to the side or things underlined, where you're quickly describing what each individual does. Remember, this is a reading heavy passage, and whatever it helps you to remember what you read is what you need to do. For me, it's making notes out to the side more than underlining. Number 34, based on the description of the demonstration, so here's the demonstration, were the bubbles that formed more dense than the surrounding water or less dense? So it says bubbles began to form in the water and float to the surface. So they floated to the surface, so that means they did not sink to the bottom. So we can easily dismiss F and H just based on what it says. And now you just have to know the definition or idea of density. So if they're floating to the surface, that means they're less dense. So a little bit of knowledge there. But even if you didn't know that knowledge, which hopefully you do, you could eliminate F and H because it says the bubbles went to the bottom, and that's not what is claimed in the reading. So J is the answer. During the demonstration, bubbles were observed to form below the water's surface. This information contradicts the explanation given by which student? So that's going to be student 3. That's the one that says there's a sheet formed on the surface and air pressure creates bubbles. If you understand the reading, these questions become decently easy. Which students stated or implied that bubbles contain gas molecules? So we definitely have student 1 has oxygen, student 2 hydrogen and oxygen, student 3 it says a mixture of gases, air only, and student 4 water vapor, gases from it. So liquid, the water changes from liquid to gas, which is water vapor. So students 1, 2, 3, and 4. According to students 1, 2, and 3, the process of forming bubbles involves which of the following changes? So chemical bonds formed or broken. Well, student 3 specifically says new bonds are created, nothing is broken. So we can eliminate choice B. There's nothing really stated about kinetic energy. So it's really just about bonds being formed in each one. And it says it in the reading for each one that new bonds are formed. So the answer is A. That's just a reading question. Did you understand what you read? I think this might be the hardest question for many students. I don't like the wording of it, actually. It says, suppose that after a student gave the responses, the teacher filled a balloon with a mixture of hydrogen and oxygen. So further, suppose she held a lit candle to the balloon and then the balloon exploded. Held a lit candle to the balloon seems a bit, I don't like that phrasing. Anyway, based on this information, which of students 2 and 4, if either, would be likely to claim that an explosion would have occurred during the original demonstration if the teacher had held a lit candle above the surface of the water? So water vapor is not going to explode, but oxygen separated by itself would. So it would be student 2 would be the one to claim that. So that's a tricky question. It's one you have to think about. You have to have a little bit of knowledge there. Pretty difficult question for the end of the test if you save this passage for last. Which student's explanation is the most scientifically accurate? And this is a knowledge question as well. So this test has 5 knowledge questions in it, I think, maybe 6, which is a pretty heavy dose of knowledge questions for a science test on the ACT. Anyway, which student's explanation is most scientifically accurate? And that's definitely going to be student 4. The water changes from liquid to gas, if you know just the process in basic science. So that's a pretty easy question, but still knowledge. Which of the following balanced chemical equations summarizes student's 2 explanation? So student 2 says H2O breaks down and O molecules are formed. They break the bonds. The H atoms do not dissolve, so you're left with hydrogen and oxygen. So H2O becomes hydrogen and oxygen.